Okay, this is VK3AML with the regular Saturday night test on 147.475 megahertz and on YouTube Live. If you care to dial up YouTube Live by Googling VK3AML 24 July 2021. That's VK3AML 24 July 2021. You should get us. Just hang on a sec, I'm switching to off-air monitoring. If I can find the right plug. And the right plug has been found. Okay. Tonight I've prepared, partly because of the nature of recent discoveries, historical discoveries, and partly through people's interest, an episode of historical material going right back to the start of radio and beyond. We've managed to find several video clips, several film clips of the pioneers of electrical engineering. Sir Oliver Lodge, born I think 1851, and William Bragg, born 1857. That's from memory. Oliver Lodge was the person who gave the world the tuned circuit, thereby making possible multiple radio stations working on the air simultaneously. Up to that time, nobody had worked out how to achieve tuning. And William Bragg, based in Adelaide in the early part of his career, 1890s, managed to do the first public exhibition of radio telegraphy, wireless telegraphy in Australia in September 1897. He was beaten to the punch, as we found out only this week, by a Melbourne man named G.W. Selby, George Selby, who lived in Alma Road, Caulfield. And you'll hear a lot more of him as the night goes on. So with these film clips, I've interspersed them with material that has no commentary. So to make them sensible to people listening on 147.475, which I hope is going okay at the moment. Just checking the current meter, it seems okay. We'll, from time to time, read out a narration for what is being seen on the screen. If you can, please do have a look at VK3AML 24 July 2021, the live stream, the YouTube live stream, and you may do better with us there if you have problems with reception or so forth. This is VK3AML, now going over to the pre-recorded material, I hope. He hopes. This is W.H. Bragg, a young man bound for great things in science. His early part of his career, although he was born in Britain, was at Adelaide University, where his early work in electricity led him to make this wireless apparatus in 1899. He had been working on it for a couple of years up to that stage, but he made a film in 1931 talking about his predecessor, Michael Faraday, whose position at the Royal Society in London by that time Bragg then occupied. This film was made in the engineering laboratories of British Thomson Houston in 1931. William Bragg, one of the first people with radio in Australia.
The scientific work of Michael Faraday, son of a blacksmith, and in his youth a journeyman bookbinder, has been of the greatest importance to us all. If his experiments and researches had never been made, the mechanism of our modern life might have been entirely different. For instance, I doubt if I should have been able to speak to you by means of the talking film, as I'm doing now. Michael was born in London in 1791. He had none of the advantages of modern education. At the age of 13, he was entered as a newsboy into the service of a Mr. Rebo, a bookseller and bookbinder of Blandford Street. A year later, he was taken on as an apprentice to the bookbinding trade. He was very anxious to improve himself, and he seized the advantages which his business gave him because he read deeply in the books that were brought to his master's shop to be bound. He tells us himself that his interest in electricity was aroused by his reading an article on electricity in the Encyclopedia Britannica. In 1812, a good chance befell him. A friend of his gave him tickets by which he could go to the lectures at the Royal Institution of Sir Humphrey Davy, who was the inventor of the miner's safety lamp and was then at the height of his fame. Faraday took careful notes of these lectures. He wrote them out in his beautiful script and bound them all into a book. Here is the very book which is still preserved. You see his beautiful handwriting. This book he took to Davy, and Davy was very interested. Faraday asked him if he mightn't enter in some means upon a scientific career. Davy tried to dissuade him, saying that probably the bookbinding would pay him better. But a little while afterwards it happened that Davy had to dismiss his assistant, and so he sent for Faraday. A chaise and pair invaded the little street where Faraday lived, and a footman descended from the box, and there was a note from Mr. Faraday asking him to come to the Royal Institution, and there he was engaged at the rate of 25 shillings a week and 2 rooms in the top of the house, and began his scientific career as bottle washer to Sir Humphrey Davy. Now, at that time, Faraday entered upon his experimental work and rapidly showed a great aptitude for it. In fact, it wasn't many years before he had advanced so far as to succeed Sir Humphrey Davy. Faraday was particularly interested in the relation between magnetism and electricity. One such relation was known in his day. I can illustrate it in this way. If I join up this wire to the battery here, then a current of electricity runs through the coil, this coil. And at once you see that the coil has a magnetic effect. And if I put this piece of iron in the coil, you see the effect is still greater. Look how violent it is now. In fact, I can put it into these nails, and you see I can draw a file from out of the cup. But Faraday was convinced that there must be some other connection between magnetism and electricity than this which I've just tried to show to you. Many had tried to find this connection, and at last he was the one to succeed. Here is a coil, and here is what we call a galvanometer, an instrument for recording the passage of a current. You see that when this magnet here lies alongside the coil, nothing is happening, the needle is quite upright. But if I take the magnet and push it into the coil, you see the needle kick. Now I pull it out again, you see it kicks violently again. Thus you see the magnet has an effect in generating electric current, and that is the simple basis. Dynamos, motors, all the mechanism of modern electrical engineering springs from that. That's the important point. It took the genius of Faraday to find it, and then to work out its principles, and then to make it plain to the public. Let us picture to ourselves Faraday working in his laboratory on August the 29th, 1831, the day on which success came to him. We have pictures from which it has been possible to reconstruct the theater in which he gave his lectures and did many of his experiments. He's now trying the experiment I've just been describing. Though his arrangement is a little more difficult to explain and to understand, also it is comparatively primitive. He has taken an iron ring and wound 2 coils upon it. They're of bare copper wire, the various turns being kept apart by string and tape. There was no insulated wire to be bought in those days. This ring is still preserved at the Royal Institution. He connects one coil to the ends of a wire, passing over a magnetic compass some distance away. He joins the other coil to a battery. Do you see a little movement of the compass just when he makes this last connection? Let's suppose that he has missed that. The needle is back in its old place by the time that Faraday looks at it, and he does not realize that anything has happened. He stops to think. Then perhaps he breaks the connection and happens to be looking at the needle at the right moment, and he sees the needle move. How excited he must be. After trying it over and over again, he goes to his desk to write in his diary, and here is the actual page as he wrote it a century ago. This was the beginning of great scientific developments and of industries employing millions of men. Let's picture to ourselves one other experiment that he did. He is pondering over this strange influence that a magnet can exert in his neighborhood, and he tries to examine it by placing a card over the magnet and scattering iron filings upon the card. Others have done this before, but it didn't mean to them what it now means to Faraday. See how beautifully the filings arrange themselves. Faraday supposed that these mapped out the lines of force of the magnet, as he called them, and as electrical engineers have called them ever since. Finally, let's picture to ourselves some of the consequences of Faraday's work. Think of a powerhouse, of a factory with the motors running, of trams and trains, of a magnetic crane, of a telephone exchange, of the X-ray room in a hospital, of water power generating current, of telegraphs and cables and wireless, and see how great all these consequences are. Now, I've no time to describe you more of Faraday's work, but I hope I've said enough to make you realize what a great Englishman this was and what a right we have to be proud of him. And you will understand, I am sure, the interest attached by exhibitors and by electricians all the world over at the centenary held in 1931.
The Australian radio pioneer William Bragg introducing his predecessor at the Royal Institution, Michael Faraday, who you see in these very early photographs. Well, where do we find equipment such as Faraday used to describe how the 19th century people first demonstrated wireless? Well, there's a group in Italy, which you're about to see the videos of, the Fondazione Scienza e Tecnica Firenze. It's basically a scientific institute set up in 1850 who have kept all of their demonstration instruments in working order. They have just in the last few years put up a series of videos of that equipment demonstrating these various physical principles. They call it the cabinet, but it's much more than that. It's the best collection of scientific instruments from the 19th century surviving in Italy. In fact, they have furnished rooms and premises, collections, everything is got to working order if they can do it. And those who are on the YouTube live stream are actually seeing some of the instruments at the moment. You'll see them in detail shortly. It was possible to acquire the tacit knowledge necessary for realizing the experiments illustrated in 19th century treatises. Observing an instrument in operation is much more effective than reading their descriptions. It supplies essential elements for better appreciating the significance of experimental physics. The historic value is communicated by the use of original instruments and their techniques. But the realization of live experiments with historic instruments involves many problems. Conservation, long preparation times, uncertain results, subjective observations, harmful materials, dangerous situations. The solutions? Videos. Simple, basic, rapid, clear, the voice of the instruments with explanatory captions, and that's what this group in Florence has done. Their videos contribute to the understanding of classical physics. They are a resource when visiting the First Museum at Florence. They make the most of the collection. With them it's possible to understand the functioning of the instruments. In addition, they have a global and free diffusion through the web. They can be used by other museums. These videos can be used by schools, laboratories, universities. They're used by ham radio operators at the moment. Therefore, wherever you are, their instruments are with you. And they're with us tonight. For those who can't see them, I'll do a description of what we're seeing on the screen. This is VK3AML. If you dial up my VK3AML 24 July 2021 YouTube stream, you'll find us. Induction coils. Induction coils are electrical transformers which work with a periodically interrupted DC current in their primary windings. First we see a toy induction coil producing a 1 or 2 millimetre spark. In this small induction coil, the current in the primary is interrupted by a simple hammer interrupter, a buzzer. A medium-sized induction coil with a 4 to 5 centimetre spark. In this coil the current is interrupted by a more sophisticated hammer interrupter of the APS type. Its functioning is more rapid and regular than a simple hammer interrupter. Finally, the large Ruhmkorff coil with a 15 to 20 centimetre spark. It's connected with a Foucault's mercury interrupter, which you'll hear working in a minute. There we go. These are periodically interrupted by 2 electrodes dipping into cups of mercury. One of them operates an oscillating arm. Frequency of oscillation, fairly slow, is regulated with a sliding spherical mass. The second circuit is connected in series with the primary of the coil and interrupts the current flowing into the step-up transformer, generating a very high voltage pulse. You can hear the pulses going across a spark gap now. Adjusting the high tension side. The Ruhmkorff coil can operate a large Geissler tube. These were colourful glass tubes with evacuated glowing gases that could produce spectacular coloured effects, very favoured by 19th century people who'd never seen electric light before. We set the coil, the induction coil, into operation, and the Geissler tube lights up with its uranium glass, yellow, green, blue. It's hard to describe what I'm seeing on the screen. Glad we're running a YouTube live of this. All this was leading to wireless communication eventually. Now we'll see a large induction coil, a large spark coil with a Van Helt interrupter. It's a sort of an electrolytic interrupter. A large porcelain insulator has a small needle of platinum pointing out the bottom, and this is dipped into a bath of acid in series with the primary coil of the step-up transformer. By electrolytic action, the anode and the cathode are immersed in a vase diluted with dilute sulfuric acid. The interrupter is in series with the primary of the coil and a source of continuous current. And as the bubbles occur around the point, the Van Helt interrupter can interrupt the current up to 1 kilohertz, passing considerable current and glowing in the acid. The cycle is repeated to more than 1,000 times a second by that type of interrupter. You can probably hear the sparks flying there. All of this was around in the 1860s and 70s. With the Van Helt interrupter, the spark can reach 40 or 50 centimetres. And all of this is being shown on original equipment of the 1870s. Electrical discharges in a tube during its evacuation. Another scientific display. The terminals of an induction coil are connected to a tube which is evacuated with a hand-driven double-barrelled pump. The atmospheric pressure has the sparks jumping across the normal spark gap with the evacuated tube in parallel. But as we evacuate more air, more current flows through the evacuated tube. Continuous glow gets seen, and the electrodes start to show a strong luminescence. Pumping the air out of the tube. We're now seeing two glowing electrodes. A dark space appears in the discharge at a certain point, which also starts to show a series of stratifications in the discharge. And that's the sound of the vacuum pump from the 1870s, still working in Florence. This is VK3AML. Just repeating, you can see this on our YouTube live stream. When the tube is open and the atmospheric pressure is re-established, the discharge stops inside the tube and starts across the spark gap. Now a Tesla coil, a high-frequency resonant step-up transformer. The terminals of a large induction coil are connected with the internal armatures of two Leyden jars, big capacitors, and with a micrometric spark gap on the primary, maybe 100,000 volts on the primary. The external armatures of the jars are connected in communication with the primary of the Tesla coil, a few turns of thick wire. The secondary is many turns of fine wire. Input voltage 100,000, output voltage probably 1 million. And now we're seeing the discharge from the top of the Tesla coil. In fact, the voltage gradient near the main electrode of the Tesla coil is so high that fluorescent lamps or Geissler tubes, gas discharge lamps, will light up without ever touching the electrode. I think these are rather wonderful videos, actually. It's a great thing that this Florence organisation in Italy has made them all available to us. A selection of Geissler tubes from their collection. These are gas discharge tubes that were purely made for enchantment. Not made for any practical purpose. A glass blower's nightmare, as you can see, in twists and turns with different types of gases introduced them in low pressure so that they glow, and often made of uranium glass which will glow green under ultraviolet excitation, adding to the colourful effect. This is G.W. Selby as a young man who was actually doing demonstrations quite like that in 1880. And this is an advert from 1880 where he was showing electric lights in a vacuum at an exhibition at the Eastern Market in Melbourne in 1880. Sir William Crookes, another experimenter with high voltage electricity, the inventor of the Crookes tube, which you'll see in a moment. Another point leading the way to radio. The Crookes tube produces an electron stream which hits an oblique metal plate, and by varying the charges of two deflection plates across the electron stream, top plate is negative, you can see the deflection of the electrons negatively charged towards the positive plate. You can also demonstrate the effect of a magnet on the electron beam. When you present the north pole of the magnet to one side of the Crookes tube, the beam will bend to the right, or in this case downwards. In using this tube, Wilhelm Röntgen in 1896 noticed that X-rays were being emitted by the Crookes tube when he happened to use a fluorescent screen near it. And G.W. Selby was one of the first Australian users of X-rays. As soon as they were invented, he got the system going in August 1896, and that's him holding up his coat, which had concealed in it a pocket leather pouch with a couple of coins in it. He also did an X-ray of a rat from his basement in Alma Road, which you see there. X-rays were soon in general use, and they used the same sort of equipment that was used for powering Geissler tubes, as you can see. Heinrich Hertz, the person who really started radio off. He has devised a means, which you can see here, of generating radio waves with a spark. Initially on VHF, interestingly. This particular generator produced them at about 2 metres. And this is a better idea of what it consisted of: a spark gap with 2 balls producing inductance and capacity on what amounted to a dipole radiator. And you could detect the transmitted pulses by using a tuned loop with a gap in it that would produce a spark gap. Whenever you threw a spark gap in the transmitting end, you'd get a spark gap in that receiving loop. It was taken one step further by a young man named Oliver Lodge, who you'll see here, and you'll hear him in a minute. He devised a type of coherer that was a much more sensitive system for detecting Hertz's waves. And in fact, Lodge later on made a major contribution by working out a system of tuned circuits. This is a demonstration of the coherer, its operation by that Florence Institute, again using original 19th century equipment. A Grenay electrolytic cell is tested with a galvanometer, an original galvanometer. You'll see the needle flick. It's producing voltage. When the zinc electrode is immersed between the 2 carbon electrodes in an acidic solution, you get the voltage. Currents generated, deflects the galvanometer needle. The cell and the galvanometer are connected in series with a Marconi coherer, which you'll see on the stand there. Glass device, has granules of silver in between 2 electrodes. And that's about to detect radio waves from a nearby high voltage generator. Not in this case a coil, but a thing called a Wimshurst machine, a high voltage static electricity machine that charges up Leyden jar capacitors. The resistance of the filings drops whenever a spark flies. There's a spark, and you'll see the flick, and then you have to tap the coherer to decohere the filings, set it back. That was the basis of the first radio telegraph transmitters and receivers. Spark transmitter, coherer for reception. There's the coherer, an original Marconi model. Hertz experiments with electromagnetic waves. It's not generally known that Hertz's first electrostatic generators could generate pulses up around the microwave region. This one works up around 500 megahertz. And it's been set in this case, as you see if you're on the stream, in a parabolic reflector. You key up the spark in the middle of the reflector at one end, and the coherer will respond at the focus of another reflector. And ring a bell. A gentle shock on the coherer re-establishes its non-conductive state. The bell stops ringing. So you can focus those radio waves. Now this is a demonstration. They now try it by putting a copper sheet between the 2 reflectors. There is no reception. However, if you put the copper sheet across the room at 45 degrees to the two parabolic reflectors, you can reflect radio waves from the spark transmitter into the coherer, as you're about to see. This is VK3AML testing, by the way. And it makes the bell ring. The coherer is activated by reflected radio waves off the copper sheet. All this was being demonstrated in about 1894. That's when this equipment dates from. The Lodge syntonic jars, the syntonic system, or what we call the tuned circuit. Man switching on a spark coil, and you connect it into a loop in series with a Leyden jar, in other words, a tuned circuit. Now, that wasn't the important point. The important point was on the receiver. Okay, we're causing a spark to make the circuit of the tuned circuit on the transmitter. The interesting thing is, with a Leyden jar and a similar tuned loop, by running a tap back and forth on the loop, you can tune the spark receiver to the spark transmitter. That was an enormous leap of faith in the 1890s. It's the basis of all tuning systems subsequently, and it made Oliver Lodge a lot of money when he had to come to a settlement with the Marconi Company, who had pirated the idea. And another video from the Florence people. Oliver Lodge, in extreme old age, at the age of 84, actually made several films in 1934, and this is a film of Oliver Lodge recalling his background in electrical engineering.
I have lived from the very beginning of the electrical age that is now upon us. When I was young, there was no such thing as a dynamo. If we wanted a current of any magnitude, we had to mess about with Grove's batteries, consisting of zinc, platinum, and acid. And it was a troublesome business. I remember that the name dynamo was invented by Lord Kelvin when I was secretary of the British Association. I was secretary of Section A of that body. I remember seeing the original Pacinotti machine. It soon developed into the Graham armature. And then ingeniously the Siemens firm introduced a double winding and produced the modern Siemens armature. There had been an old Siemens armature with an iron rail wound longitudinally, which was shown at the 1862 exhibition, producing strong currents and exciting much interest. It was no easy matter to get a really strong current in those days. Covered wire was almost a novelty. While to make connection between different things, there was no notion of plugging in two terminals. We had to screw up each wire with a binding screw. A pair of binding screws were the only terminals. I remember the first electric lamp shown to the telegraph engineers, that's now the institution, by Sir Joseph Swan, which he said would serve well for a reading lamp and not require any matches for its lighting up. And a little later, I remember Colonel Crompton coming for one of the conversaziones at University College London and bringing a number of such lamps which he arranged in the entrance hall, festooning them as an exhibition. He came himself and superintended the erection with extraordinary energy, taking possession of Carey Foster's laboratory and having it all rigged up in time. I remember, too, the first visit of Graham Bell and his demonstration of the telephone at South Kensington, when he lectured to the Physical Society in a beautifully articulate manner, pronouncing everything completely and accurately. He was just the right type of man to make a metal disc speak. Then Hertz made a great advance. He discovered how to produce and detect waves in space, thus bringing the ether into practical use, harnessing it for the transmission of intelligence in a way which has subsequently been elaborated by a number of people. Now this present century, which has made so many undoubted discoveries in physics, seeks to discredit and deny the ether of space. And I want to conclude this talk by a few words upholding its reality. It is the ether which conveys waves in the fraction of a second to the antipodes. And it is that which brings us information from the stars, from the most distant nebulae, which otherwise we should be without. The ether is the seat of all radiation energy.
Oliver Lodge was interested in life beyond life as a result of losing a son in the First World War, communication to the beyond. However, he was a highly respected electrical engineer. He fostered the talents of John Logie Baird, for example, and lent his gravitas to the earliest demonstrations of television. Here he is sitting in front of Baird's TV camera in 1927. He also made one of the first recorded film talkie lectures in 1929 on empty space, on the ether as a concept.
I am at King's College, London, in the Wheatstone Laboratory. Once presided over by John Hopkinson, now controlled by Professor Ernest Wilson, who was lent for the occasion. I'm going to speak about emptiness, vacuum, what we commonly call empty space. We are usually concerned with matter, which consists of particles. But I'm concerned with the space between the particles, or the space between the worlds. Space which we commonly call empty. It makes no impression upon us. And whether that space contains anything or whether it is really empty is partly a matter of opinion. I prefer to call it ether, but some people prefer to call it simply space. The name you give to it is of no consequence. The first thing we learn about empty space is that it can be thrown into vibration, tremor, a quiver. You use this tremor when you toast bread in front of a fire. Or if you sit in front of a fire. People think they're feeling hot air, but they're not. They're feeling the vibrations of empty space or of ether. I am now in a bath of vibrations, ether vibrations. The result is I'm rather warm. For when these vibrations fall upon matter, they produce heat. They may produce other things too. They may produce photographic plates. Or they may produce vision. The skin is sensitive to the vibrations, and you feel them in front of a fire, or you feel them in the sunshine. The eye is especially sensitive, and I have somewhat to do in order to see in this bright light. The lamps agitate space. They agitate the ether. I am agitating the air. My voice throws the air into vibrations. The lamps throw the ether into vibrations. And there is a machine for picking them both up. By one machine you hear what I'm saying. By another machine you see what I'm doing. And they're both being recorded on the film. Now I want to show not only that empty space can transmit light easily, but that it can also transmit force. It is possible to balance a weight of an empty space. That sounds curious, but it can be done if you put the space into a peculiar state. Now, to show that, I take this little arrangement here. Here is a bar. It's made of iron and cobalt, cobalt steel. If I place it on this guide, it just has guides to prevent it tumbling about, and let it go, it oscillates. You can see it oscillating up and down. There's nothing to support it. You're not to suppose that the air supports it. It is like on a cushion, but it is a cushion of empty space, cushion of emptiness. One may explain it and put it in various forms. One knows really that there is a magnet in this piece of wood below which is repelling the magnet above. And it's only recently we've been able to show a body supporting its own weight by repulsion. But that doesn't really explain it. You're not to suppose that you understand those things because you call them names. The real point is that there is nothing supporting that. It would do perfectly well in a vacuum. Put it in as perfect a vacuum as you have and the thing would behave exactly the same. Space is what we're experimenting on. And it is because space has these physical properties that I prefer to call it ether. But the name ether has rather gone out of fashion. There's another experiment here just to illustrate this cushion of ether. Here are two bars of steel, and you see, if I, now they're trying to collide against one another. There's evidently a cushion between them. Very simple experiment. And if you look at it from the engineering point of view, of no consequence. But if you look at it from the philosophical point of view, there is something quite remarkable in the collision of particles with a cushion, with nothing but a cushion of empty space to separate them. Remember, this would go on in a vacuum too. And the real particles of matter are all in a vacuum. The particles that Sir Ernest Rutherford was talking about, the atoms, are all in vacuum. And they repel one another, something after this fashion. The worlds only attract one another, but the particles of matter can also repel. But remember that when you use the word repulsion, you're not explaining anything. One of the simplest experiments that can be shown is to rub a stick of sealing wax and attract light bodies. The ancients were interested in that. So was Sir Isaac Newton. The air has nothing to do with it. The absolute vacuum be all right. These forces are wholly affairs of the ether. The strain is in empty space. The strain may be caused by a large body like the Earth or in other ways, artificially. As you go away from the Earth, it diminishes. If you come near the sun, you find it is 25 times as great. So that a pound would weigh a quarter of a hundredweight on the surface of the sun. Some stars, the force of gravity is still greater. On an exceptional one, the companion of Sirius, associated with the name of Professor Eddington, a child would be unable to lift a lucifer match
which would weigh half a hundredweight, while a sovereign would weigh a ton. The forces that can be transmitted by emptiness are enormous. The empty space between the moon and the earth has to sustain a strain that would snap a bar of steel 400 miles thick. The properties of matter are altogether insignificant compared with the properties of emptiness. Matter looms large in our imagination because it appeals to our senses, our animal senses. But its properties have many imperfections. A thing made of matter is always temporary. It wears out, or it decays, or rusts, or evaporates, or otherwise loses its nature. Whereas the properties of empty space or ether are perfect and never change. Our bodies are made of matter. Accordingly, we have aches and pains and breakdowns and ultimately collapse. If ever we find, as I think we are beginning to find, that life and mind need not be associated with matter, but can inhabit empty space, then life will not be subject. Life there will not be subject to the troubles of a material organism, and existence will be perpetual.
Sir Oliver Lodge, born in 1851, one of the pioneers of electrical communication. This is VK3 Alpha Mike Lima with the regular Saturday night transmission, this occasion of historical materials relating to the birth of radio and its rise from physical sciences in the late 19th century, which we're illustrating with film, photography and demonstrations on original equipment. If you want to look in on this, if you're listening on 147.475, you can Google our YouTube live stream, which may have better audio quality than what you're listening to on 2 meters, by Googling VK3AML 24 July 2021. Google VK3AML 24 July 2021. And at the moment I'm trying to work out how to set up for another media stream, this time talking about the local pioneer G.W. Selby and his on-air companion Calder Oliver. Just trying to work out how to add a stream to this, and it doesn't seem to be behaving. Here we go. Browse. Okay, on to G.W. Selby, who was the first person in Melbourne ever to transmit wireless telegraphy. June 1897, Alma Road, Caulfield. Sir Oliver Lodge was very significant for a number of reasons to Australian radio communication. He not only invented the tuned circuit, syntony as he called it, syntonic circuits, now known as tuned circuits, but he also inspired quite a few people to get involved with radio communication experiments as a result of presenting his major paper on the death of Heinrich Hertz in 1894. And the first of those for Australia was G.W. Selby, George Selby. George Selby was an electrical experimenter who had been in the game for about 20 years by 1897. He had been an early experimenter with high voltage electricity, had induction coils from about the year 1879, and as we heard earlier in this presentation, he was one of the first people in August 1896 to demonstrate X-rays using a Crookes tube as the generator and the high voltage source of his induction coil. But He lived at a big house, a big Victorian pile called Yatmakera. Unfortunately, there are only very fuzzy newspaper photographs of the place, but it was a 22-room mansion on the corner of Alma Road and Khartoum Street in Caulfield. The corner now looks like this. The original 13-acre block, which extended right through to Inkerman Road, has long since been split up into small suburban blocks with small suburban houses on them. But at that time, Yatmakera was on the edge of the city. This is 1897 we're talking about, and probably an ideal place to experiment with wireless telegraphy. And Selby was the very first person to do that in Melbourne, almost without any other doubt in the matter. The person that he communicated with on his wireless telegraphy experiments was an extraordinary engineer, hydraulic engineer, and a civil engineer named Calder Oliver. Calder Edkins Oliver. And Oliver, it sounds like a joke, was the second director of the MMBW farm at Werribee, which in its day was known as a civil engineering marvel. It occupied a huge area on the western side of Port Phillip Bay. All sorts of special techniques for sewage treatment were devised there. It greatly enhanced the health of Melbourne as a place to live. And the farm itself, fertilised by you-know-what, became a model of its type, although, of course, they can't sell the produce for human consumption, only for cattle. There are films of the MMBW farm very early on, taken for publicity purposes, to show other engineers what a marvellous construction the MMBW farm, which still operates, providing sewage treatment facilities for a major part of Western Melbourne. So Calder Oliver lived in a largish house in Manor Road, about 2 streets in from Dendy Street Beach in Brighton. So the communication distance between Calder Oliver's house, which was called Tarrawarra in Manor Road, and G.W. Selby at Yatmakera, Alma Road and Khartoum Street, was about 5 miles, and 5 miles for 1897 was an incredibly long distance for wireless telegraphy, particularly on equipment that was built by amateurs. And you'll hear the story of that as I read Selby's own words from his first letter to a newspaper on the subject of wireless telegraphy. This was published in the Melbourne Age, Thursday the 22nd of July, 1897. To the editor of the Age, Sir, for some time past I've been working out an idea I had 3 years back in 1894 for telegraphing by means of the Maxwell and Hertz waves, and of course without line wires. This problem I practically solved 4 weeks ago in June 1897, but the wind has been taken out of our Australian sails by Mr. Marconi and Mr. Preece in England, who have succeeded up to a distance of 8 miles. As I had independently arrived at a similar solution to the problem to that of Marconi, perhaps some of your readers may be interested to learn that no very elaborate apparatus is required. Of transmitters, I've tried many, among others a Hertz oscillator of the dumbbell type, made out of check valves, gives me very good results. I've not yet finally decided upon the best form of receiver, but find Branley Coheres, suitably proportioned to the waves to be dealt with, give good results. Dr. Oliver Lodge, in his interesting lecture of 1st of June 1894 before the Royal Institution on the work of Hertz, indicated plainly the road to a successful solution of this problem, but curiously enough missed devising a really practical receiver. It was reading Lodge's lecture which put me on the track, as I have no doubt it has others. It reminds one of Lenard, who, although working with cathode rays, knowing their photographic power, even though aluminium and some other substances yet missed Rontgen's famous X-ray discovery. The problem of practical telegraphy at a distance resolves itself into, first, directing the waves along a definite path, second, devising extremely sensitive receivers, and third, increasing the energy of transmitters. Much has already been accomplished, but there is far more to be done. In the present state of the invention, if several Melbourne enthusiasts take up Hertz telegraphy, it will lead to most confusing signals on their receivers. Any number of people can receive from the same transmitter. There's no privacy in the method unless special codes are used. Tuning affects much but not all. Those who wish to study electric wave propagation should get Hertz's classical work Die Ausrichtung und elektrischen Kraft. A translation by D.E. Jones is procurable. The waves I use, like the Marconi waves, seem to be little hindered by brick or wooden walls or iron roofs. The sender may be in a room in a brick house with all doors and windows shut, the receiver similarly situated, still the signals come through all right. Further experiments are necessary to determine whether the waves get out at the air chinks or go clean through the walls, but I'm inclined at present to the latter view. So far as my experience goes, there's no evidence of metals being transparent to the waves, but with suitable wavelength even this may yet be attained. Both ordinary and polarised telegraph relays answer very well at the receiving station. We have yet to learn how to talk at a distance without wires and to transmit images by electricity, but these problems should not long baffle the modern scientific world. Graham Bell and Sumner Tainter's experiments and those of Minchin should be looked up if those people are interested in such problems. If Professor Lyle of Melbourne University or someone equally well up in Hertz waves lends a hand, Australia may yet beat the record. My friend Mr. H.M. Stormont has very kindly assisted me in constructing the necessary equipment, but simple apparatus is required for my experiments, and had it not been for him, I'm afraid that with the limited time at my disposal for such work, I should have been even slower in attaining my results. Yours, etc., George W. Selby, 99 Queen Street, Melbourne, 19th July, 1897. A week after Selby's initial letter to the Age sent a reporter over to Selby's house in Malvern, and this is the report that appeared in the Melbourne Age, also in July 1897, on the 27th of July, in fact. And now we come to the interesting fact that these discoveries in wireless telegraphy would, but for an accident, probably have been anticipated by the experiments of a Melbourne electrician working upon the same ascertained facts as were made use of by the English and Italian experts. Mr. George W. Selby of Alma Road, Caulfield, a member of the London Institute of Electrical Engineers, began his study of the subject in 1894 after reading the lecture given by Professor Lodge. The time he was able to give to it was, however, very much broken by his attention to other business, with the result that his experiments were not concluded till about 5 weeks ago. Perhaps it's incorrect to refer to them as concluded, for though they give a fully convincing demonstration of the important fact that clear and reliable telegraph signalling can be done without any visible communication between the transmitter and receiver, there are details to be worked out and several possibilities of further development to be followed up. Mr. Selby indeed holds that the new system offers still a vast field for inquiry and experiment. Future work will, however, be in a direction tolerably well defined. Already to some extent, the commercial value of the system and its value as a means of making communication between warships and other vessels and the land, or for lighthouse purposes, is established beyond question. In carrying out his experiments, Mr. Selby has hit upon a new form of receiver, or coherer, which gives better results than any suggested by other experimenters. A representative of the age who examined the apparatus yesterday was shown the two principal sections of it operating in different rooms of Mr. Selby's residence. The doors in each case were closed, and it's a nice problem not yet solved as to how the electric current reaches the receiver, whether it goes straight, which would mean that it goes through several feet of brick wall, or whether it follows the course of a corridor and gets under the door of the room that holds the receiver. Mr. Selby is of the opinion that the waves penetrate the walls. He was right. Anyway, the operation of the receiver is decidedly eerie. So far, telegraphy in this way is possible over a distance of about 8 miles. Whether messages can be sent much further, and there seems to be little doubt that they can, will depend upon the extent to which the ether waves can be directed along a given path and the degree of sensitiveness which can be imparted to the receivers. In connection with the suggestion that the system might be used for destroying torpedoes, Mr. Selby says there is no evidence that the ether waves penetrate metal hermetically sealed. Moreover, he assumes that an explosion could not be produced without the assistance of a receiver on the vessel to be exploded. In a recent description of the experiments of Marconi, it was stated that the electrically charged waves would be liable to cause an explosion of, say, a powder magazine at a distance of 1.5 miles from the transmitter. It was pointed out that an admiral who rashly flashed his signals abroad in a fog might explode the magazines of his own ships instead of those of the enemy. Mr. Selby quite disbelieves that anything of the kind could happen. Well, obviously there was some improvement in their work, as by the 22nd of July 1899, a report appeared in the Melbourne Argus. Mr. G.W. Selby of Queen Street, Melbourne, who takes much interest in electricity, recently wrote to the Victorian Defence Department asking to be allowed to carry out certain experiments in wireless telegraphy between His Majesty's, Her Majesty's, I should say, Victorian ship Cerberus, which was moored in Hobson's Bay, and the naval depot at Williamstown, in order to ascertain its application for naval purposes. Permission was granted for this wireless telegraphy experiment, and Lieutenant Richardson, who has charge of the torpedo boats, was directed to render Mr. Selby any assistance he could. The trial, says the Melbourne Argus paper, was made on Saturday, when signalling between the warship and the shore was effected by an apparatus made by Mr. Selby in 1897 and exhibited him before the Royal Society of Victoria in that year. Selby is confident that his instrument will work over distances obtained by other experimenters if opportunities are afforded him to put it to the test. The department will grant him any further facilities he may require. This is the only known paper surviving substantially complete to be presented by the very first Australian radio experimenter, and that was George W. Selby of Alma Road, Caulfield. He presented this lecture at the Victorian Institute of Engineers, 57 Swanston Street in the city of Melbourne, on the 11th of November 1908, and in it he refers to that period of 5 years of heavy experimentation he did with wireless telegraphy between 1897 and the sale of a lot of his material in 1901, which terminated his experimental work. So this is a very good overview of his involvement with wireless telegraphy, and he reveals the motivations that he had for taking up that line of experimental work after years of work on electric lighting, high voltage electrical effects, and X-rays, of which he was a pioneer. Wireless Telegraphy by George W. Selby. I want you to remember that this is written in the rather flowery language of the 1890s, so please make allowances. Over to Selby. It was the reading of Dr. Oliver Lodge's lectures and the account of Tesla's experiments and apparatus, as well as Hertz's work, that first suggested to my mind the possibility of a practical wireless telegraph. It is now some 12 years, 1896, since I first experimented with Hertz waves with a view to utilising them for electric wireless telegraphy, and some years since circumstances compelled my discontinuing practical work on the subject. Let it be remarked here that the best results have been obtained in long-distance telegraphy by means of long waves, and that the wavelength is approximately between 4 and 5 times the height of the sending wire or antenna in the earthed form of the Hertz oscillator. Please note, even in 1908, Selby knew that he could transmit with a quarter-wave vertical antenna against ground. Back to Selby. The resonator devised by Hertz was quite unsuited to the purpose of wireless telegraphy, and the small sparks required absolute darkness and a microscope to enable one to perceive them at any considerable distance from the oscillator. In 1884 and 1885, Signor Calzecchi Onesti rediscovered the fact that metal filings enclosed between two metal electrodes acquired the power of conducting when exposed to the direct influence of extra currents, induced currents, and sonorous vibrations. This had been previously noted by Professor Hughes, the inventor of the microphone or telephone transmitter, who in 1879 observed phenomena which he attributed to electrical waves even before the discoveries of Hertz, but not being understood, these experiments were soon forgotten. In 1890 and 1891, Edouard Branly, a Frenchman, made much more complete researches and discovered also that certain metals acted as anti-coherers, or offered increased resistance when exposed to electric radio waves or variations of potential. Professor Oliver Lodge and Professor Threlfall of Sydney seem to have been the first to publicly propose the possible application of Hertz waves to telegraphy, and Professor Crookes, in February 1892, pointed out very clearly the road to be followed. Tesla showed about the same time that what are known as high-frequency currents could be transmitted to considerable distances by the use of two vertical antennae terminated by capacities, capacity hat. Mr. Popov, in Russia, employed a coherer and vertical wire to record atmospheric disturbances. Lodge made use of filings tube and also of a single contact coherer. Finally, in June 1896, Guglielmo Marconi, an Anglo-Italian, patented a system in which he used a Ricci oscillator for sender and a filings tube or coherer in connection with a tapper as a decoherer at the receiver. It's frequently been said that Marconi did nothing new or original, that his oscillator was Ricci's, his receiver was by Lodge and Bose, while his general arrangement was that of Popov. In the language of Mr. L. Poincaré, the persons who thus rather summarily judge the work of Mr. Marconi show a severity approaching injustice. It cannot in truth be denied that the young pupil of Ricci had brought a strictly personal contribution to the solution of the problem he proposed to himself. Apart from Marconi's forerunners, and when their attempts were almost unknown, he had the very great merit of adroitly arranging the most favourable combination, and he was the first to succeed in obtaining practical results. He showed, in fact, that the electric waves could be transmitted and received at distances enormous compared to those attained before his day. According to a well-known anecdote relating to Christopher Columbus, Sir William Preece very justly said, "The forerunners and rivals of Marconi no doubt knew of the eggs, but he, Marconi it was, who taught them how to make the eggs stand on end." Mr. Marconi was most fortunate in meeting with a man at once so generous and enlightened as Sir William Preece, who, although engaged on other methods of wireless telegraphy in which he was preeminent at the time, and holding as he did the highest position in the British Post and Telegraph Department, nevertheless at once extended to Marconi the right hand of friendship, and by his assistance and encouragement, it's not too much to say, contributed largely to the young Italian's success. I can add my own testimony to this, for I found it impossible to work in any way reliably with the filings tube or point contact or ball contact described by Dr. Lodge, and had great labour before I devised a similar receiver to that of Marconi. Some of the numerous forms devised by me are on view here tonight. Now, the invention of a reliable coherer, simoscope, or electrical wave detector in itself constituted an essential advance in the domain of electric wireless telegraphy, for only by means of some extremely sensitive detector or of a responder to electric waves could we hope to receive signals, to record the fact that a train of electric waves was passing the receiving station, and to intercept and use some of the energy so conveyed. For are not the waves radiated in every direction? The filings tube of Lodge was long, cumbersome, unreliable, and comparatively insensitive owing to the difficulties in adjustment. To indicate some of our troubles, we must remember that a tube of filings might be of any size, both as to bore and to length, that filings and pole pieces could be of any metal, that filings could be of all sizes, that the distance between the pole pieces could be varied widely, that many or few filings or combinations of different metals could be used. Then the filings might be oxidized or unoxidized, in a vacuum, in air at ordinary pressure, or in other gases, damp or dry, etc., etc. And I'll halt the video there to say at about 11 o'clock I'll be calling for anybody who wants to chat on 147.475. I hope people understand this is a paper, one of the first complete papers on wireless telegraphy ever delivered in Australia by the first man to demonstrate wireless telegraphy in Melbourne, George Selby. And this was for many years almost hidden within Melbourne University archives, this particular paper, very recently digitised, so I can kind of represent it here. Thought it was worthwhile doing. George Selby was the first Australian radio amateur, June 1897. And back to the video. Until 11 o'clock. 11 o'clock I'll call CQ on 147.475. This is VK3AML testing, and with the YouTube live stream, which you can look up if you so desire. It's you Google the phrase VK3AML 24 July 2021. That's Google the phrase VK3AML 24 July 2021, and that should take you to our live stream. Back to the recording. The very files were a source of trouble when it came to a question of great sensitiveness combined with reliability. The Coheres, as shown by Dr. Lodge and verified by many others, could consist of a single point contact or a quasi-contact. I tried every metallic element I could procure in Melbourne in the 1890s, as well as many alloys and carbon, also the use of a magnet to regulate the sensitiveness of the filings tubes. Ivory I preferred for the containing tube, unless the filings were to be enclosed in a vacuum. In the case of carbon, I got anomalous results, which have since been found by Thomasina to be due to automatic decohering. The telephone was also used by me as a receiver in conjunction with an aluminium plate or sheet, and promising results obtained. Tesla coils and Leyden jar condensers arranged on the various known plans were also used, and a new form of Tesla was devised. Experiments were carried on by me at distances from a few yards up to half a mile, and ultimately from Malvern, where I lived, to Brighton, where Calder Oliver lives. In my later work, my friends Mr. Calder Oliver of the Metropolitan Board of Works, Mr. Wilfred Curnow of the Working Men's College, and Mr. Stormont all led their kind assistance. To do this, the former gentleman, Mr. Calder Oliver, had to go to the expense of having a suitable mast erected at Brighton. For senders, at first Hertz oscillators of various forms, in conjunction with vertical and horizontal wires, were used, then condenser discharges and transformers, both with oil and air cores, as well as glass and ebonite were tried. The wave detectors, receivers or cymoscopes were as follows: metallic filing cymoscopes or coheres, anti-coheres, as of made of antimony or mercury, etc., Schaefer's damped slit, self-decohering coheres of carbon and mercury carbon, self-cohering decoherers of the electrolytic type, magnetic cymoscopes, such as those of Marconi and others, and single-contact cymoscopes. Among those used extensively, the Castelli iron or carbon mercury coherer of the Italian Navy, as used by Marconi in transatlantic work, may be mentioned. Lodge's self-decohering coherer consists of a revolving steel disc with a knife edge just touching the mercury surface and overlaid by a thin oil film. Fessenden's thermic receiver consists of a V-shaped silver wire 0.05 mm in diameter with a core of platinum wire 1/5000th of a millimetre diameter with a very fine point of V-type dissolved away by nitric acid. The rate of signalling using a telephone is 65 words per minute, but the wire is very delicate and too thin for ordinary handling. Fessenden's liquid barretta consists of a diaphragm with a minute hole in which a fine platinum point is inserted. The hole is immersed in acid. It can be used for prolonged low-tension waves and with shorter antennae only 12 metres high for 100 miles range with a 1/4-inch spark. Then we have Dr. Lee de Forest and E.H. Smythe the responder, consisting of a glass tube similar to that of a coherer, in which are fitted 2 electrodes, preferably of tin, separated by 1/64th of an inch, filled with a viscous semiconducting liquid such as glycerin, a little water and some peroxide of lead. Professor Ernest Rutherford found in 1895 that oscillations sent through a coil surrounding a very small steel needle, which had been magnetised to saturation, could more or less demagnetise it, and made a detector, a magnetic detector for electric waves on this principle. Others followed him, and in 1902 Marconi described 2 other forms of magnetic detectors or cymoscopes, one of which has been successfully used for long-distance work. Some of the more sensitive receivers can only be used with the telephone, and although a fair rate of signalling can be attained, it's set up to 65 words per minute, they have the disadvantage of not recording the signals on a tape. The Brown Coherer consists of 2 steel electrodes adjustably mounted by means of a screw and held in a tube of hard rubber. In the interspace of the highly polished inner surfaces of the electrodes are placed 30 or 40 steel granules. The smaller the granules, the greater the sensitiveness. A magnet can, of course, be used to alter the sensitiveness. There are many other suggested detectors, but the above are the principal and the most satisfactory. Unfortunately, with the filings coherer, the more sensitive it's made, the more difficult it is to obtain satisfactorily regular signals. That extremely sensitive receivers are necessary if great distances are to be covered is self-evident, for the energy of the sending station is radiated in all directions and only a minute fraction of the power used can be received at the distant station. The limits to the sensibilities of the receivers and the necessity for working well within those limits to attain reliability have naturally turned the attention of inventors and the companies supporting the more fortunate ones to devising means for increasing the power radiated from the transmitting station. Numerous have been the alterations made in the mode of exciting the sending antenna as well as the design of the latter. The original simply modified Hertz form has given way to one or other of the Thomson, Kirchhoff or Tesla devices. For long distances, the explosive energy of the close-coupled antenna is used, while to effect signalling and render possible simultaneous or multiplex wireless and duplex telegraphy, a loose coupling seems desirable between tuned circuits, if not imperative. Unfortunately, with the former, stations operating near one another simultaneously interfere, while with the latter, the distance to which the signals can so far be sent is reduced enormously. The men who have done most to improve the sending appliances by devising means for employing much greater power at the sending station and for increasing the amount of energy radiated have been Lodge, Muirhead, Brown, Hertz, Selby, Arco, Fleming and Marconi, and much has also been done by these inventors in the direction of effecting more reliable tuning between the circuit of the senders and the receivers at both stations, so enabling greater distances to be covered on the one hand and on the other to have rendered possible simultaneous multiplex and duplex signalling to be carried on at moderate distance with more or less success. And I'm just interrupting the recording there to say we will be having a callback, a QSO, hopefully, if anybody comes up, on 147.475 2 metres in about 4 minutes' time. This is VK3AML on a test transmission with George Selby's presentation to the Victorian Engineering Institute in 1908. George Selby was the first person in Melbourne to transmit wireless telegraphy. Back to the lecture for the next 4 minutes. In the present state of wireless telegraphy in 1908, it cannot be denied that much remains to be done before this system can be compared for reliability to cable or connecting wire systems. But the field for the useful employment of wireless telegraphy is already very large and quite beyond the reach of other systems. Installations for 600 or 700 miles are now quite in the ordinary. 3,000 miles are already said to have been covered. The progress in 12 years since 1896 has been marvellous, and now that the installations are on the higher power scale involving steam engines, dynamos and transformers, we must expect further knowledge regarding practical difficulties to be overcome and still greater advantages in the future than in the past. Literature on the subject is already fairly extensive, the chief works being by Fleming, Vreeland, Eichhorn and Mazzotto. But the most important work has been done on the mathematical and theoretical side by Abraham, Brown, Seat, Zenneck, Bjerkins, Hertz, Drude and many others, among the Germans, to say nothing of Poincaré, Turpin, Ricci, Thomson and MacDonald, Peirce, Tissot and Ewing. It is said that wireless telephony has also been accomplished by Mr. Collins in New York, over some 81 miles. So my prediction in the age of July 1897 is already being partially fulfilled. Following the end of this George Selby's lecture, there was a discussion, and the discussion fortunately was recorded in shorthand verbatim, so I can give it to you now. Actually, I'll stop it there and go back to a live screen. Yes, this is me, and this is 10:58 p.m. on Saturday the 24th of July 2021. I think I have my inputs right for piping 2 meters through the YouTube live stream, which appears to be going very well tonight. I'm surprised at that. I would have thought that with everybody locked down, hunkered down, that we'd have internet congestion problems, but not so. We actually lost an internet connection on Thursday night. I tried to live stream the digital slow scan net, and after about 45 minutes the whole thing dropped, not just the live stream but the whole of our internet service. So I assume it's because people are using it to an incredible extent. This is VK3 Alpha Mike Lima with a test transmission, a regular Saturday night transmission. I hope if people are in a position which has poor 2 meter reception capabilities, perhaps you would prefer to listen on our YouTube live stream, which you can get by Googling VK3AML 24 July 2021. That's VK3AML 24 July 2021. And I'll just throw in that if anybody wants to email me, email here vk3aml@optusnet.com.au. Again, my email vk3aml@optusnet.com.au, and that should find me within minutes, I think. I'll have a look occasionally over the next hour, see if anything's come through. A couple of the correspondents have already been in touch on one thing or another, and I'll just look at the text chat. Thank you for the compliments, Van Dan Escobar and Dan DTM. One thing I probably will run as a result of the interest shown in it is that 1920s documentary on the MMBW farm at Werribee, which I've only found on the internet the last couple of days. Somebody has the original Pathé film made by Herschel's in the mid-20s. And the way it boosts the sewage farm, of course, they show you everything to do with it, the pumps. There was a little town, apparently, in the Werribee sewage farm. Bits of it are still there, but they had a little town for the workers on the farm, and not as funny as you might think. As long as you were downwind, or rather upwind of the poo pans, you were pretty right. But interestingly, the film made in the 20s never touches on the, shall we say, product. You never actually see a boogie. All you see is happy, contented cows, happy, contented people, and people driving tractors. This is VK3AML, about to go over to the receiver, 147.475. If anybody would like to chat, I'll open up my usual logbook. As you may have gathered, I recorded most of tonight's stuff on a previous day, to take the pressure off me a bit in the evenings, so I can make myself a cup of coffee and not feel like I'm chatting flat out all the time, although I give that impression. Okay. Cock-a-Rock, that's right, John. Well, that town features highly in that mid-20s documentary film. It's about a 10 or 12 minute documentary. And I'm just replying to John Young on the text box. There is actually a text box that comes up beside the YouTube live stream. So, that being said, this is VK3AML now calling CQ on 147.475 and standing by for any calls.
Golf.
Sorry, who was that? I didn't have the speaker level up.
Sorry, VK3 Echo Charlie Golf. Good evening, Chris.
Yeah, hi Dave. I'll just change my monitoring over. I'm monitoring off air. When I'm speaking to you, it's better that I monitor off the... hang on. Yes. It's better that I monitor off the mixer. I'm running quite a bit of peak limiting too, so presumably when I back off the mic you'll still be able to hear me. I hope your week has been fairly good. We've both of us have come down with coughs and sneezes. Coughs and sneezes spread diseases. And so we went for a COVID test and came out clean. So heaven knows how we got the coughs and sneezes, because we haven't been anywhere. Well done, Chris. Well, thank you very much. But you may hear me wheezing and coughing through the night. So we've got Dave there. Is anybody else about on 147.475? VK3AML, standing by.
Yeah, 3ACZ.
Ah, got you, Pete. VK3ACZ. Well, we'll take Dave first. Yeah, Dave. Interesting that New South Wales has got themselves in a bit of a pickle. I think Gladys didn't shut things down fast enough. There's always a tendency by her sort of government to leave things open, and unfortunately I don't think that's the way to do it when you're letting people in from overseas. Not a good combination. You might like to make some comment on that, or maybe not, I don't know. Maybe it's a political comment, in which case I withdraw it. I love Gladys. Well, that cancels that out. VK3ECG, VK3AML.
Yes, VK3AML, VK3 Echo Charlie Golf, and good evening to you, Pete, as well. Yes, probably best nothing said, really. I mean, it's there's hard work going on in lots of quarters, I imagine, and I know sort of my colleagues in the Victorian scheme and work very hard, and I have no doubt the same things are happening in VK2 land. But yes, it is worrying when you just see the what a fast spreading virus can do. I suspect that the issue of the colds and things you get is just that, you know, we do come into contact with stuff, and we're going to get it. Fortunately, the community levels of COVID in Victoria are so low that the opportunity is lower than the ordinary common cold. But it's fascinating the degree to which colds themselves and flus and things like that have been much less because of the self-isolation, and that's been, I think, shown quite well. Yes, it's been a pleasant week. I've had a few interesting things on, but mostly trying to get some of my sort of teaching things all sorted out, which always takes a little bit of time, and fiddling around up here trying to reinstall, sort of do some work on a microphone, and in the process of which hating surface mount technology, but I seem to have collaged the thing together in some ways. Bits of extra wire are spread over the board, which is inelegant, but it is all concealed under a cover, which makes it look much nicer. But I think I might have improved the sort of punchy level of the microphone and increased its audio bandwidth. But I'm going to, I have a little mixer here, but I need to sort of get one of the Yaesu 8-pin plugs and wire that up appropriately, and then I can start using a proper microphone with a proper equalization and stuff like that. And I think that'll help a lot, and it'll be a little fun little project for the next little while. Yes, otherwise the other thing I do a little bit of is singing and so on in the choir, and of course we haven't been able to meet or rehearse for our concerts, which is a great shame, but that is, I suppose, inevitable. And we've postponed them. My daughter was also singing and was in a concert, and that concert's been now cancelled entirely. So they're going to try and record it and then make it available for those who purchase tickets and things like that. But that's a great shame. But there's lots of these sorts of things that, of course, have gone by the by, and we have to just cope with it, I think, while we can. Fascinating stuff on the YouTube channel. Enjoyed watching that and trying to understand. I presume Selby must be related to the suburb as well, but I suspect there are one or two other Selbys, so maybe not. Anyway, back to you, Chris, and then good evening to you, Pete, as well. So VK3AML, VK3 Echo Charlie Golf with VK3ACZ on the side.
No other breakers there. Yeah, interesting. Surface mount technology, I agree with you. I'm prepared to work on stuff on tag strips, but surface mount would be beyond me. My hands are not steady enough, and my eyes are not good enough. I probably could wear something like these. If you're on the live stream, you can see them there. These are they're 3 diopter magnifiers. I can put those on and see things at a distance of about 3 inches that are quite detailed. But just, I suppose it's partly unfamiliarity, but it's also partly I just balk at doing stuff that's that small, knowing how easily you can go awry. For that reason, that's one of the reasons I've got the software-defined transceiver lined up, the ANAN. I'm not prepared to build one of those. The one thing I could never build properly myself, and I used to have troubles and take the circuits round to Tony Sanderson, 3AML, to look at, as he seemed to get some success at this, was building a VFO. If you want to have a tunable VFO, building it to be stable is incredibly difficult. These days they do it by synthesis. In the 70s you didn't. You did it by using a capacitor which had one sort of temperature coefficient against wire on a coil, a tuned circuit, that had the opposite temperature coefficient, using some special type of ceramic capacitors called NPO ceramics, which I think had a zero coefficient or something. But it was all very complicated, and so I think best left to factory-made surface mount components. Hello to Paul 3HN there. Nice to hear you there, and Mark Harrison as well. You're teaching, I'm in which field? Would it be the forensics? I'm not sure. Selby. Now, Selby, yes. George Selby had many strings to his bow, apart from the fact that he was Australia's first radio ham and an experimenter with electrical equipment, particularly high voltage, spectacular electrical equipment back to the 1870s. He was also one of the directors of the first Australian electric supply company in the city in about 1883. Later on, he joined the firm almost at its birth that he was to be with for the rest of his life as an auditor, made a lot of money from that because the firm which he joined in 1886 became known as Broken Hill Proprietary, and he stayed with it until he retired, I think, in 1941. He died at the age of 92 in 1949. So he was with Broken Hill Proprietary for a very long time, and I think the weight of that business actually drove him to sell off his electrical equipment in 1901. We've located the comprehensive lists of equipment for an auction house dating from that year. So that's why he got out. He was making money in other areas, but he also had a farm in the Dandenong Ranges up near Gembrook. You know what I'm leading to here. And mixed farm, I think largely fruit and veggies, and quite large and quite productive. And he became a council member up in the Dandenong Ranges for a large part of the 1880s and 90s, and he politicised towards opening a narrow gauge railway from Upper Ferntree Gully to Gembrook. And that was opened in, I think, 1904, and there was a great to-do about having a station named in his honour. The station was called Selby, still is called Selby. It's only a little waysiding on the Puffing Billy Railway. But since then, the locality up in the Dandenongs has become known as Selby, and that was, in fact, from George Selby's work. So he was an extraordinary man in all sorts of ways, knew how to make money, combined that with being quite a talented electrical experimenter, although he could see that there was no huge money in it. I think that's why he got out of it. But also was not aware until I found that Melbourne University transcript of the paper he gave in 1908. He was incredibly literate, incredibly articulate. So I actually met his son, I think his son's name was Dave Selby, in 1972, and Dave Selby was then in his 80s, and it was at a place called Albert's Stamp Centre, our Albert Stamp and Record Centre in Cookson Street, Camberwell. Albert Isaacs, he used to run a stamp place, later was involved with the rail fan shop, and Mr. Selby was one of his stamp buyers. Mr. Selby Jr. was from Kahuna, up near Echuca on the Murray, and would make trips down. Anyway, I got chatting with this guy. I was about 18, he was about 86. He was intrigued that a young person was interested in radio and started talking about his father, and subsequently he sent me a letter which I must dig out and scan, along with a couple of copies of x-rays his father had taken in 1896, including that rat x-ray. That led to the research that nearly 50 years later ended in what you heard tonight. It's just interesting that this guy was living in our midst, and he's virtually one of the forgotten men of Australian history. So I'll hand it over now to Peter, VK3ACZ, with a pause. But if Terry, VK3FTJS, is listening, and I know he's on the live stream, I know you know a bit about the internals of the Werribee sewage farm, and particularly the little town that used to be there called Cockerock. It'd be interesting to hear your reaction if you saw the film earlier on, Terry, how it compares. I'll have to give you the URL for that, Terry. The film is not on YouTube, it's on Vimeo, Vimeo, and if you look up MMBW Farm Historical Material, it's about a 10 or 15 minute film, I think, made by Herschels in, I would guess, 1925. That's just a wild guess. Anyway, and Peter, this may be of interest, Dave. I've been lined up to talk about the light beam comms on Deal Island for the next meeting of the Sherbrooke Amateur Radio Club, which now meets in a church hall in Baronia. and it's the first Monday of August. But I've got a feeling that the chances of it being on are pretty slim at this stage, unfortunately. But means that this coming week I'll be editing up all the necessary video material. VK3ACZ. Peter, with a pause, VK3AML.
VK3AML in the group from VK3ACZ. Good evening, Chris, and good evening, David. Good to hear you both, and it's good to have our regular Saturday night thing, which is becoming a bit of an item, and pretty good. I've been looking forward to it. Yeah, Chris, first thing you said last week that you felt a little bit secondhand and you were going for a COVID test, and I didn't really have any doubts that you'd have much of a drama there, and it sounds like there wasn't any. You mentioned at the start of the broadcast having a cold or other, and I came down with a rather nasty rhinovirus, I don't know, a month or two ago, and of course I wasn't at all concerned about the idea of it being COVID, but my ex-whale left me to sleep on the couch, home quarantining. Admittedly, she did offer to sleep on the couch, but I wouldn't come at that. It wasn't her fault. But she went and got a COVID test, so that's how I know I was fairly confident I was clear there. But anyway, to get on with the broadcast, and glad you were well too. Faraday, oh, what a guy. My favourite part of the whole thing, and of course it's horses for courses, just because it's my favourite. It doesn't mean that the rest of the broadcast fell in a hole by any means. No way. Sometimes I'm as impressed with Faraday as I am with Newton. That's a bit of a silly call, really, because there's no comparison with some of our geniuses, and they all had their different roles to play, of course. Whenever I think of Faraday too, I think of the Faraday suit or the Faraday cage, and the Faraday suit particularly because those very brave lineys get on the 500 kV lines and do their inspections and all that, and yeah, clearly it works. And when I was in Westminster Abbey, I actually thought that Faraday was buried there because there's a plaque for him very near Newton's, but I think it was only the second time I went to Westminster Abbey I realised, no, it's not his resting place. He's not residing there. And if truth be known, each time I've been to London, which is twice, I've been, well, and if I ever get to go again, Westminster Abbey will be compulsory, because I go there to sit beside Queen Lizzie and her half-sister Mary that sit in the same box there. I just find there's something incredible about that place. But anyway, next subject. I didn't have the advantage or assistance of YouTube tonight, but I want to give you a compliment because the broadcast lacked absolutely nothing because of your superb verbal commentary that filled in all the spaces for me. You know, there weren't really any gaps, so thanks for that. And on to George Selby. Yes, I was prepared for that. You'd already demonstrated your knowledge of Mr. Selby because Graham, VK3DLW, who's also a member of the Sherbrooke Club, he came up, I don't know, a month or two ago, and you then demonstrated off the top of your head that you had a very good knowledge of the fellow. So all that was very interesting to hear as well. And the MMBW poo farm, oh yeah, I'm all interested, and I had a bit of a chuckle when you said what the name of the little village, township, whatever it was called, and I don't, Cockleberry or something. Yeah, sounded pretty funny. Anyway, more stuff to convey, but this is enough for one over. I'll hand it back to you, and yeah, another great broadcast. A VK3 AML in the group, VK3ACZ.
AML, FTJS.
Yes, Terry, I'll call you in next. VK3FTJS. I know that Terry has been watching the stream, but the stream is 32 seconds delayed, I believe, from the radio broadcast, so there's a time differential. I actually have it purposely set to a long delay because if there are irregularities in the speed of the internet stream, you need some latency there to pick up the slack. When the internet's running slow, you have to have a bit of a pace ahead to take up the slack as the speed goes up and down like a yo-yo, particularly in these days of shut-ins and people watching lots of cable TV. So I have the I have the latency on the stream set to maximum, hence 32 seconds. I probably could get the latency down by choosing the appropriate tab, but it would probably compromise the continuity of the stream and potentially lead to a crash. So I haven't been game to change it. I am, however, this week running an audio peak limiter before the computer so I can move around a bit more without worrying about levels. And I should tell people here, Terry 3FTJS has had some odd jobs in his time, but I met him on CB radio some 20, maybe 25 years ago. I was talking to this guy on CB radio and he said that he was at the gate of the MMBW farm. And back in the 70s, Tony 3AML used to lead groups of amateurs down to go into the farm when there was no bar on the gate. We'd go to the mouth of the Werribee River, we'd set up an antenna and go on 160 metres portable and usually have a barbecue, would you believe? Which was great as long as the wind was blowing in the right direction. But Terry was on the gate. Apparently they now have guards because they've got some fairly exotic equipment in the farm for recirculating things like methane. No doubt Terry will tell you more about it. Terry was on the gate guarding the farm, and I had to ask him, are you there because of the turd burglars? And that set up a roars of laughter in both directions, and we started making every poo joke under the sun. I think we've been friends since then, haven't we, Terry? Anyway, with that, I will hand it over to Terry, and then back to VK3ECG Dave. VK3FTJS, VK, hope you don't mind that intro, VK3AML.
Not a problem, Chris. No, security industries are a vast and very widespread thing, and we worked on that I worked on that for a couple of years solid, and it was an interesting place to work. It does have the best beef stock in Melbourne, or in Australia for that matter. The herds are now run by elders herds, and they're the biggest herds in Australia. Tasmanian University's also in there as well. Victorian University's in there as well. They have research facilities as well in there, and also the town of Cockorock. There's only a small hall, the water tank, and the football oval. That's the only three things that have really survived. Oh, and the Stockman's place. But as you know, Chris, it's changed a lot over the years. And as for the grey water it comes in, it goes into methane holding ponds, then goes into the aerators, gets aerated, then gets pumped on the fields, then gets filtered through them fields, and then out into a lake, and then out of that lake into the back into the ocean.
Yeah, they go in that film. They go into the usage of the seepage and the way it's all purified to the point where it can be drunk. Although I wouldn't be game personally, but put it this way: if I was forced to drink the stuff, I don't think I'd die. It's just slightly the thought would be a little bit off-putting. Anyway, we'll go back to Dave, VK3CG and the group. What are you teaching, Dave? I'm just curious. VK3AML.
Yes, VK3AML and the group, VK3 Echo Charlie Golf. Yes, well, I do a range of teaching, mostly tertiary stuff, and because we're sort of part of a department of Monash, so I run a couple of courses in a master's program, and our organisation does that, so we run this master's, and I cover a couple of courses, and one of them runs twice a year, which is the one I'm doing this time, and that's basically around witness training, actually, so it's witness training skills. So and it's part of the program we have for sort of doctors and dentists and things like that. So it's quite it's interesting, and I get a chance to play the lawyer and put them in the witness box and give them a tough time. It can be quite amusing, and then we will sit around and critique each other and how they've done and things like that. So it's one of those sort of, it's actually quite practical because it relates to the sort of work they're doing rather than sort of a generic stuff. But we cover all the basics and things like that. So it's quite a fun thing to do. Yes, it was interesting, the whole Selby issue as well, and I realised it probably had to be. Most of these people were fabulous entrepreneurs, really, weren't they? I mean, sort of the concept of the gentleman scientist I quite like. It's got that touch of Holmes in it, hasn't it? And the issues around Lupin, whatever the French gentleman thief, and so on. So there's rather sort of nice ideas. I'd love at some stage to see that rat X-ray. You showed a very quick picture, I think, of it on the YouTube, but that looks fascinating. Fascinating to see. Yes, these surface mount technologies drives me crazy every now and then. I actually bought some dentist loops some time ago, sort of just one of these sort of cheap things from Amazon, and they proved to be fantastic. They've been really, really good, as I just find I need incredibly strong light and trying to get a diffuse light, so I finish up with 3 light sources over my sort of working desk, so to try and get a sort of shadowless field of view. But the loops are really good, and although a really strange thing happened to me the other day, last week I got a parcel which appeared to be sort of dressed, well, it was dressed to me, but contained some other equipment from the same place that I purchased these loops, these sort of glasses, little telescopes on, and and I couldn't understand why I got this, because I hadn't ordered anything, and of course I couldn't look anything up on because I hadn't put an order in. And eventually this a jeweller from New South Wales contacted me and said, I sent all this stuff back to you, but Amazon hasn't got it. And I said, well, I don't know why you sent it to me, because I've got nothing to do with this company. And it turns out the company, he was returning stuff to the company. They had sent out the packaging instructions with some stickers which had my name and address on, one of their other purchasers, not their name and address. So now I've got to go and return it to him. So it's one of these classic sort of stuff-ups of online purchasing, and I suppose we'll get a few more of those with the lockdown and things like that, and all those things driving me crazy. Anyway, and good evening to you, Terry, and so back to you, Chris. VK3AML Group, VK3 Echo Charlie Golf.
Yeah, VK3CG and Group VK3AML. Yeah, thanks for that. With the witness training, when you first said it, I thought you said witless training. And I wondered, is this going to develop into a Spike Milligan sketch or something? The getting of ignorance. But yeah, I would guess it's for some sort of legal coverage. And you say dentists are involved with it. I can't imagine. Are we talking about dentists who are expecting some sort of legal issue? Oh dear. Now, Peter, Faraday. Interesting. I don't know whether you saw all those videos taken at the Science Institute. What's the name of it now? See if I can pronounce it. My Italian pronunciation is not great. Fondazione Scienza e Tecnica Forense. They have that marvellous collection of 19th century, what they used to call philosophical instruments, heavy electrical demonstration equipment, projection lanterns. They've been collecting this stuff for their physics teaching since 1850, and consequently they have one of the best collections of physics education material, demonstration equipment anywhere in the world, particularly for the 19th century, and a lot of it late 19th century relates to things like coheres, spark transmitters, Hertz redoing Hertz's experiments and Oliver Lodge's experiments with Leyden jars and loops to demonstrate how the idea of a tuned circuit came about, the parallel inductance and capacitance, which Lodge pioneered. And, of course, demonstrating it, now they've got onto the fact that by putting it on video on YouTube, it makes it worldwide accessible and multiplies its usefulness. I suspect the fact that they've done it for free means that there must be some very laudable people who've been generous with their time restoring the equipment, along the same lines as Puffing Billy Railway with steam enthusiasts. I only wish I could have been involved with the restoration of that gear myself. It's fascinating stuff, particularly the high voltage stuff. I mean, it creates enough of a spectacle to see that gas discharge stuff and the long sparks. Now, imagine how that must have affected an audience who didn't know electricity from a bar of soap in the mid-1870s, suddenly to see all of that. And hello to VK3BRS Rob and 3K3BYY. VK7MJ has also been watching, but I think he goes to bed fairly early these days. He's always lived out in the country and he tends to keep bushy's hours. Hello to you if you're watching, Mike. So we've got viewers in Hobart and one in Canberra, I see. Gosh, there are 17 at the moment. It has been as high as 19, so we're doing reasonably well. Peter, Faraday, one of the instruments that they have in that Florence collection is a device to demonstrate the Faraday effect. And Michael Faraday investigated the effect of magnetism on all sorts of materials. He discovered diamagnetism, D-I-A-M-A-G, diamagnetism, which is that normally if you have the poles of a horseshoe-shaped electromagnet, you switch it on, magnetic material will of course align between the north and south poles. There are materials, diamagnetic materials, that will turn the other way, certain types of glass. And an effect called the Faraday effect can be demonstrated if you use a particular type of glass. I think it's a particularly dense glass, either flint or crown, I forget which, flint glass. You put a block of flint glass between the poles of a really strong electromagnet and you shine polarized light through the two. You can rotate the plane of polarization of the light by varying the strength of the magnetic field. Now, that would be hard enough to investigate now. To have done it in the late 1830s just blows my mind. So I can understand why you're impressed with Michael Faraday. It's extraordinary. And in the film, Bragg pointed out, what makes it even more impressive is that in Faraday's time, insulated wire was unknown. Imagine winding a coil. VK3 ACZ in the group, VK3AML, choking to death.
VK3AML in the group from VK3ACZ. Well, don't do that, Chris. We still need you. Hi. Yeah. Oh, yes. Light and electromagnetism are related. Yeah. Good old Mr. Faraday. And not that he caused the effect, but I'm very grateful every time I'm in a car and there's a thunderstorm raging. It's nice to know that you're safe. But, yeah, he's related to that in a way as well. An absolutely brilliant mind, and I never stop fantasising in my mind about going back in time, which would be a bit of an effort in itself, wouldn't it? But to talk to these people and to see what they were like, I hope they wouldn't all be quite as difficult as, say, Volta, but yeah, never mind. A couple of things to tell you. First of all, I still had chuckles about the MMBW works. That was, Terry, that was some great commentary you gave us there about the place. Very, very interesting, and I'm still trying to get used to the fact that there are guards on it. But and Chris, you did mention something about not being too keen on drinking the stuff. Well, I was thinking how astronauts drink their own urine after it's been refined, of course, and as David can attest, and I can remember from my nursing notes, urine is 96% water, 2% urea, and 2% mineral salts, but still, it's the thought as much as anything. Who knows where the stuff out of the tap comes from, but yeah, to have it directly offered to us, well, that'd be another step again. And something else to remind you, Chris, off topic, but Monday night, 19:30 hours, 3 RHA upway repeater. The club net is on. Jim has got a very funny little thing on the web page there. I won't tell you what it is, but every couple of weeks he puts up a cartoon or similar, and there's one worth laughing about there. To do with having to unload some of the gear because there's not enough time for amateur radio and everything else you've got to do, including cleaning the house. But anyway, suggest you have a look at that later. Only other thing I'll offer at this point is that with the lock-up with me at the moment, things are crook here. No DX. What I do with my logbook is that each time I have an overseas contact, which I know DX is apparently not including ZL anymore, or so some people say, but whenever I get an overseas contact, it has the green marking, what do you call them, the highlighter through it, and I've got a couple of pages here in the logbook and no green on it at all. That's because I've got the nasty QR Mary, my neighbours 2 doors down, are growing their latest illicit drug crop, and that wipes out all my HF bands except 10 metres, and because I'm not able to go portable now, well, it means that I don't get up the hill to put up the squid pole and do a bit of DX on 20 and 40 metres especially, so a bit sad about all that at the moment. The lock-up can't end soon enough, and as for your concerns about whether we'll have our meeting on 2 Mondays' time, well, let's wait and see. It doesn't pay to get our hopes up too much, but it also doesn't pay to get too despondent about it all, and yeah, I just can't wait until Dan says we can get out and do our thing again, or even if it was made a 10k limit, that would help. Anyway, enough this over. Back to you again, Chris. VK3AML, VK3ACZ.
Yeah, thanks, Peter. I'll certainly make an effort to get the video finished. I have 3 sections of video, 2 that I did and 1 that Dave 3ASC did. I have to lop them all back to the point where the whole thing is a half hour. I'm also looking at borrowing Steve 3SL. If he's listening, I hope you don't mind me doing this, Steve. If I can borrow Steve 3SL's video projector, it's the full 1080p and it's very high resolution, very high screen brightness. I know that you've got a data projector at the rooms, but it's I think it's only VGA and only standard def and fairly dim, so it's okay for putting up diagrams, but if I can do better through Steve's projector, I shall. Most of my own video is shot in 4K. I can trim it back on the editor to 1080p. Anything lower than 1080p to me these days looks not so great. In fact, I'm not so amused by the fact that I have to stream 720p at the moment. I can actually vary the stream upload rate independently of the pixel number that I'm running, and I think it does it by blurring movement at the lower streaming rate. But next week, if there are no crashes this week, and I don't think there have been even so much as 1 lost frame, I might up it to 1080p next week, because the webcam is capable of it. With 1080p on that webcam, it's a strict pixel-to-pixel mapping. But when I run 720p, it's actually down converting to 720p, so it's not that great a 720p resolution. One of the, I'm gradually pushing the boundaries back on to see how far this YouTube live thing can go. I'm pushing it back in terms of video production. I was a little worried actually tonight that I'd made the whole presentation too serious, that the physics side was being emphasised and it was becoming a bit dry and academic. So I'll try to pick something that's a little bit lighter next time. However, I think it stands up okay, and the fact that I've got between 16 and 19 people fairly continuously on the YouTube live stream indicates that it's has some sort of an audience, even if it's a specialist audience. We get usually also about 160 hits a week on this stream once it's recorded. And I know that some people watch it by intentionally by time shifting because they're morning people, not evening people like me or you. And they prefer to watch it early in the day when they're fresh. I'm not fresh in the morning. I'm a member of the Society for the Abolition of Mornings. I'm a lazy little bastard, in other words. Anyway, round to Terry, VK3FTJS. Any more details of the farm you'd like to give us, Terry? It'd be interesting to hear what's happened to the area that we used to go to for our field days. We used to go to a group of pine trees that used to be near the mouth of the Werribee River, on the south side of the Werribee River. The north side has a marina now, only had a beach in the old days and I think one tuck shop, but on the south side there was nothing. It was basically a dirt road going to the beach and a grove of pine trees, but I think the pine trees have gone and they've been replaced by something like a methane producer. In other words, still producing hot air. Not surprisingly. VK3FTJS with a pause, VK3AML.
Yeah, that foreshore area, it's still a little park down the end of 160 Road South, and yeah, the methane plant, yeah, they built there, and that was pines all the way from there all the way up until halfway up the Werribee River. But over the years the pines have been taken out and so forth. Then you've got Riverbed Flats, which is down the cliffs, which goes down onto the river. You've also got what else was there? There was the pines, yeah. So you're basically opposite the mouth of the Werribee River, sort of around onto the beachfront. Is that right, Chris?
Yeah, that was where it was. We actually have 8mm film that was shot there in the late 70s. I think Dave has a video transfer of it.
Yeah, what I'll do, I'll sit down over the next couple of weeks and I'll draw up a map. I'll get the old map and I'll go through and I'll point out a few locations to you and what was what. And yeah, it might be interesting to just put with your archives and you'll be able to refer back to it.
Yeah, well, I'll send you the link to that film made in the mid-1920s when Cockorock was really buzzing. I mean, there's film of about 50 school kids in the local school, local farmers, the main street, general store, post office. It had the works. Back to you, Terry.
Yeah, it was a fully self-sufficient area. It had schools, works. Like most of the guys down at the farm, they reckon it's only, like most people think, it's just involved with the sewerage, but there's a lot of other stuff that's gone down there, agriculture and, as you know, the bird sanctuary out on the lake. And, yeah, but then methane plants, they're there to capture the methane off the top of the, you'll notice some of the front ponds are actually covered. They've got tarps over them, and yeah, what it does, it pulls the methane off the top, and yeah, they burn the methane off and generate energy, and that energy is put back into the aerators and everything to run the farm.
Yeah, okay. It's a fascinating place. I remember going there in the 70s, and what really impressed me was a lot of raptors down there, a lot of hawks and those sort of things, eagles. And I presume it's because the rabbit population there is incredible, and I suspect that there'd be rats about somewhere too. Plenty of food for the raptor population to pounce on, and not too much human interference. There are parts of that farm area that just are never visited for fairly obvious reasons. There's another part of the farm that I suspect is not visited because it's near the Werribee Open Plains Zoo, and you're likely to be attacked by a rhinoceros. Imagine explaining that to the hospital. I got attacked by a rhinoceros. How would that look on a death certificate? Anyway, I'll hand it round to Dave before it gets too silly. VK3ECG, VK3AML.
Yes, VK3AML group, VK3 Echo Charlie Golf. Well, stranger things have happened, that's all I can say. Yes, sorry about the, back to the thing about the teaching. Yes, these are basically people who may have to give evidence in court and as experts and so on, so it's part of a sort of training program for them for learning how to be experts and do their give their sort of evidence in various trials and things like that might come up. So that's how it all comes together. Yes, I was sort of had just been having a very interesting quick look at the YouTube on Florens FST, which is the site with those fantastic videos of the experiments using the original machines. It's absolutely amazing. And of course I came across the Lichtenberg figures, something that I really like, and that's when you discharge high voltage onto sort of resin plates, and they bring it out by sort of yellow sulfur and red lead powder, and it gives you this wonderful sort of filigree pattern, like the branches of a tree and so on. And we actually, it's a medical name, Lichtenberg figures, because that's what happens if people get a high voltage electric shock. You actually get this pattern in the skin. It's very classic, easily identified sort of finding. So, occasionally there's a story of somebody found in a field sort of, and you see this pattern on their skin and they've been hit by lightning. It's an absolute classic sign, and there it is, the experiment being carried out at the museum, and actually discharging onto these resin plates, and then they bring out the fascinating patterns, and they're quite beautiful, and people put them in glass and things like that as well, so really quite fascinating. I mean, the Royal Society's a fabulous place. I remember as a child in school going up to London, and the various schools would book tickets for those wonderful Christmas lectures that were given by a whole variety of people, and I went to a couple of those when I was at school and so on. They're absolutely fascinating. Of course, the furniture's the same. That's the same bench that all those experiments were performed on, hundreds of years ago. It's quite extraordinary. It's an extraordinary place. Anyway, back to you, VK3 AML and the group VK3 Echo Charlie Golf.
Yeah, VK3CG, VK3AML, and I have to stop saying yeah at the start of each over. It's an affectation that I have to get out of. It's what you've told me about the Royal Society is one of the reasons I have to get to Britain. I worked at the Museum of Victoria for 2 years, 1984-85. It was a temporary position. I could have applied to continue, but I chose not to. I wanted to do some other things. But I was assistant curator of electronics and communication there for those 2 years, while the permanent curator was seconded to help produce the Story of Victoria exhibition for Victoria's 150th anniversary, 1984, I think. And in that time, I had control of things like Wimshurst machines, static electricity machines, early X-ray tubes, from going back to the 1890s, Geissler tubes, Ruhmkorff coils. We had them. And then my boss, who had done a doctorate in Britain, said there's one great difference between our collection and the collection of the Royal Society or of the Science Museum, South Kensington. He said, here we have a Wimshurst machine. Here we have a high voltage coil, a Geissler tube. At the Science Museum, South Kensington, they have Michael Faraday's electromagnet. They have Heinrich Hertz's transmitter, and they have Wimshurst machines that belong to Lord Rutherford. There's a bit of a difference. There's a sort of, the provenance tends to put them in a completely different sphere. And I hope to live long enough to get over there to have a good look, and hope to be there at a time when they have stuff that I'm interested in on display. And certainly, although Britain is no longer the great military power it once was, it still is an intellectual mainspring, I think, in Europe. And may it always be so. Around to Peter, VK3ACZ, and the group, with a pause, in case anybody else would like to break in. VK3AML.
Nothing heard. VK3AML and the group from VK3ACZ. Well, there's another feather in your cap or a string in your bow or whatever that didn't know about, that you were at the State Museum there for a time there, Chris. I loved the place when I was a kid. Spent a bit of time in there looking at exhibits. Totally fascinated. One of my favourite things, and I think we've discussed it before, was going in to see where the Sunday Wireless Institute broadcast used to be in the early 70s. And I only remember looking in at a glass window at something like a studio, with the microphones there and a few dials and meters and whatever else in boxes behind it all. But the planetarium was another place I liked to spend time at. Always got to see whatever the new show was, and of course that's all at Science Works now, with the old sewerage pumping station, which funny that that should come to my mind when we're talking about the Werribee Sewerage Farm. But Terry, you're a goldmine of information. That's, again, I said it in the previous over or two, but I'm still fascinated with what you've contributed there. Thanks very much for that. And yeah, it's interesting that you didn't stay on at the museum, but as for your comments about visiting the old Dart, I've absolutely loved it there. As I said before, I so wish I could go back there. We don't have the history here, as you know. We've got a couple of 100 years, and that's all. Even over the US, I don't get a profound sense of history because they tend to demolish a lot of things except for the great historical monuments, Lincoln Memorial and that sort of stuff. But it's in England where I started to see, gravestones that were 400 or 500 years old and buildings that were 600-700 years old. Mind you, Europe is full of that as well. But it's a whole new world, Chris, and I completely understand your desire to get out there and see that part of it, and let's just hope we can. VK3AML in the group, VK3ACZ.
Yeah, very true. I mean, there are all sorts of places I want to see in London. Science Museum, South Kensington, Royal Photographic Society. One particular one that's been on my list for a very long time is the Alexandra Palace, where high-definition, so-called high-definition television, it was high-def to be 400 lines, 405 lines in 1936, but to see the place where it all happened would be fascinating, although I believe it's a fairly empty space now. It does have some displays. Incidentally, if people have been watching my YouTube live for a few weeks, you'll notice that I look a lot less red now than I did on previous weeks. I looked like a real red wine drinker. And I couldn't work out what was going on until I realised, delving into the software, that the webcam was set with the saturation absolutely flat out. So I looked like an old wino. Not that I look much less bad. I mean, it's cold in here tonight, so my nose tends to go a bit red. But it's interesting that, you know, as the weeks are going by, I'm delving into the software and finding all of the winkles in it, including the recording software that makes it easier for me to pre-record material for this at times which are more convenient for me early in the week, as material turns up on the internet, for example. And then Van Dan Escobar on text just said, I look much more human looking. Yeah. You know, one of my earliest schoolgirl crushes turned up on one of the first weeks on this. She didn't spend long on here. I think she actually thought that I was bright beetroot red. Gave up. I'll have to invite her back for another look. Not that I'm expecting anything. God, we're both 67 now. Couldn't get up to any hanky-panky. God, at our age. I mean, the girl... I had the crush on the girl in 1968. Oh, dear. Anyway, with regard to surface mount, no, I won't take that on. Anyway, I think it's over to FTJS now, Terry. I've never... The one part of the sewage farm I never went to was that lake at the southern end called, wait for it, Lake Borry. One hopes that they've changed the name with the passing of the years, because a certain section of our indigenous population might take extreme offence at that. But I believe there's a large lake at the southern end getting down towards Point Henry and the Avalon airfield, and I've never been to that end of the sewage farm. I'd be curious as to what's there, if you're still there with us, Terry. VK3FTJS and the group VK3AML.
Yeah, well, that whole lake and the area around it is all bird sanctuary. So yeah, it's permitted area. So you have to get permits to get in there, of course. But yeah, once you've got access, yeah, it's there's a lot of things down there, Chris. It's yeah, a lot of you were mentioning the birds earlier, the raptors and stuff, and yeah, the hawks used to like coming down and grabbing either a rabbit or a tiger snake. Yeah, there's quite a few snakes. The infrastructure in the place and the ecology is really out there compared to society around Melbourne. It's like, as you said, it's a walk back in time. You've got oversized mushrooms growing, and you've got cattle that are massively well fed, and yeah, because they eat the grass that the grey water's filtered through. So yeah, it's a rather interesting place, and it all interlocks with each other, and it's like 10,000 kilometres of road in there, and people really wouldn't understand it.
From memory, pardon me, have to have a good oik. From memory, Terry, looking down from the top of Flinders Peak in the Yuyangs, it's like a checkerboard. You know, roads on levee banks with big settling pans either side in it, miles and miles of it. But in terms of the untouched parts of it, the sanctuary parts, there's not much of the bay's shoreline that isn't developed now. I mean, Point Cook is now subdivided right up to the gates of the RAAF base. That's only happened the last 10 years. Around the Bellarine Peninsula, there's only a little patch around Indented Head that doesn't have houses on it. And the only part of the bay that's really not built up apart from that is inside the old Portsea Officer Cadet School. So there's not much of the old bay left. You know what I mean, Terry? VK3FTJS, just for a quickie.
Oh, most definitely, Chris. Most definitely. Yeah, that land is very valuable, and yeah, as you've noticed in recent times, they've been selling bits and pieces of it. It's becoming less and less towards the freeway, and it's moving more towards the coast. The houses are taking up the freeway side of things, and yeah. But, I mean, it's progress and everything else, but yeah, I think it'll be quite a while before that any of that land's sold, yeah, because of the contamination, obviously, in the soil. There probably would be some sort of residue, and now they actually process a lot of actually toxic stuff down there, so as in chemical and stuff. So yeah, it's an interesting place, to say the least. But yeah, as there used to be a saying, yeah, SH happens around the place, and yeah, it usually does.
Just before we hand it on to Dave 3ECG, Terry, I remember years ago having a discussion with you on stuff that they find filtering the sewage lines, and things like wedding rings and watches turn up, which they can frequently get back to their owner. Question is, would the owner really want them? Can you recall anything of that nature? What turns up in the filters? VK3 FTJS, VK3AML.
Yeah, well, there's actually a boat that goes over and takes the solids out of everything over this lake area. It's called the Mudcat, and yeah, it goes. It's all it's designed to do is just go through and take the solids out. And what it does, it spits it all up on a bank, and that's all put in the fields and compressed. So basically, they take an old field and then fill it up with that, and then over a period of time, people will come in, and either they'll get the precious metals out of it. So they basically sell the dirt off for precious metals, and yeah, it's a reasonably high secure area, but yeah, there's a hell of a lot of gold and stuff that comes down, because yeah, the obvious people put their hand down, ring slides off, don't realise it, press the button, and away it goes.
Creating a archaeological treasure trove for people 1,000 years hence. Round to you, Dave, VK3CG, VK3AML.
Yes, VK3AML on the group, VK3ECG, yes. Doesn't bear thinking about what might be found in these places, but yes, lots of things find their way to the eventual pathway. I noticed actually, I was looking and that they still had some of the, even up to, was it 1955 or something, still had the open channels for sewerage. So some areas outside Melbourne still had open channels without the sort of underground drainage systems. It's extraordinary when you think about it, how late on that was. Yes, the Science Museum South Ken's absolutely fantastic, and I must admit it's another one of my visits I used to delight in. I had an aged aunt who used to take me to museums and so on, and I always wanted to go to the Science Museum, and it's great. It's just on the underground. There's this interesting sort of underground tunnel you walk through from to South Kensington, and then you can come out to Runkman of the museums and so on, and it's a fabulous place, and not too far from the Albert Hall. So I used to go up for concerts in the evening and go up in the afternoon and spend the afternoon in the Science Museum, and then make my way up to the Albert Hall for whatever a concert or whatever it was in the evening. So it was a really fascinating place, and so on all the sort of working sort of demonstration things you could have a go at, which again a bit like Science Works, but as you say, the classic thing was actually having the original machinery of some of these people, which is astonishing, really, when you think about it, isn't it? Yes, I was thinking about Alexander Palace and Crystal Palace and the transmitters and so on. I've got this vague story. I don't know if it's actually sort of vague memory of a story. I don't know if it's anecdotal or not, of a guy who lived fairly close to one of the main transmitters. Perhaps it was Crystal Palace, but who had wired up his house in such a way that it acted like a giant antenna, and he was apparently actually powering the lighting system of his house off the transmitter. Maybe it's apocryphal, but apparently there was this sort of downstream shadow area that was caused, and it was the detection of the downstream shadow area that caused investigators to discover what he was doing. I don't know, maybe it's true, maybe it's not. Perhaps you know, Chris. Over to you. VK3AML and the group VK3 Echo Charlie Golf.
VK3's CG and the group VK3AML. I haven't heard of anybody doing that with VHF, but I heard a story years ago. I think Dan Van Elken, the late Dan Van Elken, told me this, and this would have been 50 years ago he told me, and he's probably relating to something that happened 20 years before that, so we're talking 1950s. But the story I'd heard was the Voice of America used to have its chief transmitting aerials and transmitters at a place called Greenville, North Carolina. And there was apparently a caravan park that was in line with one of the major beam antennas. They have these big curtain arrays like they had at Radio Australia in Shepparton. And this guy knew a little bit about radio and built up a fairly high-gain beam antenna pointing back at the beam that was transmitting from the shortwave transmitter. Anyway, the story was that this guy actually managed to run 200 or 300 watt lamps off the output on, I think, 11 or 15 megahertz band. And there was this particular transmission on 11 or 15 megahertz that went on evening time, his time, so he could actually power the lights in his caravan off it. Okay, he got the broadcast schedule from the Voice of America and worked out what time it was that he could safely get up on his roof and manipulate the connections and the material for the antenna. And all went well until one day he was manipulating the antenna, and the ionospheric conditions had changed, so they changed the schedule for the station. Apparently the guy was fried. I don't know that I shouldn't laugh, but some people set themselves up for the Darwin Award, don't they? Oh dear. I really shouldn't laugh, but I've watched too many Laurel and Hardy films. VK3ACZ and the group VK3AML.
VK3AML and the group VK3ACZ. Well, I'm still trying to choke back fits of laughter about people losing rings, sticking their hand down toilet bowls. That one got me going. No, I think I have too much pathophobia about fecal bugs to want to stick my hand down the S-bend and lose a wedding ring. But anyway, obviously other people do. So that was a bit of fascinating information I never would have contemplated in a million years. And talking about harnessing the effects of or the energy from RF transmitters. I lived at Mount Dandenong for a while, and even though I understand the basic idea of ionising and non-ionising radiation, I still used to worry about the possible health effects of having such a huge amount of stuff there in the atmosphere or being all around me. And you were reminded because, TV reception was difficult because of overloading and but one of the things you mentioned, Radio Australia, when I used to do my Shepparton overnighters and stay in a motel and run the service back next morning, I'd take the railway car up and have a look at the antenna farm that they had there, or, well, the towers with what just looked like a huge, massive cobweb of wires going in all sorts of directions, and could never figure out how it all worked. But what used to amaze me about that is when I took my little communications receiver up, I didn't dare even turn it on when I was too close for fear that I would cook the internal workings of it. But it was amazing how you only had to be a couple of kilometres down the road and it started to disappear into almost nothing. Again, absolutely no ground wave clearly, but as I said, I've often wondered about the effects of living next to Mount Dandenong. So if you're suggesting somebody fried themselves on the basis of Voice of America, well, maybe there's something a little bit in it. Anyway, hi, all good fun. Back to you, Chris. VK3AML and the group VK3ACZ.
I shouldn't really make jokes about it because, RF burns are pretty bad because they start on the inside of the body and work their way to the outside, which is kind of yuck. You can do yourself terrible injuries with RF, and we're having a bit of a debate on my Facebook page last few days. A lot of people who perhaps don't know too much about what the implications are in a dB scale, politicising to try and get Australia's ham radio transmitting laws raised from 400 watts to a kilowatt, and most of the people who are going for the high power are bother boys. By that I mean they're people who are into my transmitter's bigger than yours. Basically, it's phallic competition. It's my dick's bigger than yours, and those sort of people often don't have a worry about how much trouble they're causing neighbours or indeed bringing disrepute on the hobby. And frankly, I wouldn't like to be living next door to somebody running a kilowatt every night. Shielding the equipment here is hard enough as it is, even with VHF. And I always point out that 400 watts, raising it to a kilowatt is 4 dB. And if you're on HF and there's a fade of between 12 and 20 dB, nobody is going to notice 4 dB. Furthermore, I had a talk about this whole thing to Nigel Holmes, who was formerly with Radio Australia as their programming person. He would look up the ionospheric prediction charts and work out what areas should be served with what frequencies at what times. And Nigel was saying to me, well, with the rule of thumb, to make any significant difference to your power, your received strength in terms of power output, you have to raise the power by a factor of 10. Anything less than that, and it's hardly worth the trouble. So raising it by 2 and a bit, who are they trying to kid? dB scale is logarithmic, not linear, and people tend to forget that. I'm probably in the minority, but I want to keep the law the way it is and stick with 400 watts. If you want to increase your signal to noise on HF, the best thing to do is to find a friend with a farm, get yourself a software-defined radio and work your radio remotely on the farm by internet, because the farm's going to have a lot lower noise than you will in the suburbs. My voice is starting to go with this cold thing. I will have to wind it up shortly. It's 4:15 midnight. Who do I hand it on to? I think it's on to Terry, VK3FTJS, VK3AML.
Yeah, not a problem. All right, Chris, I might pull a pin and kick back and finish for the day. And thanks for running the net anyhow, and thanks for everybody participating and everybody online as well. It's always a good net, and we'll see you in the same bat channel, same bat time, same bat day. Yeah, talk to you then, Chris. 73s.
Okay, Terry, all the best. We'll probably talk to you on text chat on Facebook, Stalkbook. It's interesting the reactions you get from people there, and I know I have quite a few ham radio people on my Facebook page. It's nice to keep in touch that way. I wouldn't be on Facebook if it wasn't for the fact that my travels have got me friends in America and Britain and various parts of Australia who are difficult to keep in touch with on any other basis. It's like doing a mail out when you put up a photograph. So Dan DTM, thank you for coming up on text, as well as Van Dan Escobar, John Young, Mark Harrison. Mark Harrison makes the comment, I have some diamagnetic pyrolytic carbon. It floats above a magnet. I'll have to find out about diamagnetic pyrolytic carbon. I must say I haven't heard of it. I'm sure it's a real thing. Rob Dott, thank you for being there. Mark Harrison particularly. He blames his sneezing on the weather and being locked up inside with various heaters blowing around. You might hear a noise in the background. I've now got the fan heater going. I can measure the temperature by looking at my image on the screen and seeing how red my nose is. And if the nose goes really red, it means it's down around 40 degrees, and I have to increase the temperature or look like a wino. Okay, round to Dave, perhaps for a final. VK3ECG and group VK3AML, and thanks for coming up, Dave.
Yes, hi there, Chris, VK3AML and the group VK3ECG. Yes, it's, I know what you mean about the cold weather. As I said, the only reason for having valve amplifiers sitting next to me at the moment is the warmth from the valves. And the 6V6s that's just glowing quietly. If it gets very cold, I can put my fingers above the little grill, and it's very nice. Yes, well, yes, RF radiation and so on. Well, there's very little evidence at all for any sort of problems from ordinary RF, apart from, as you pointed out, the nastiness of RF burns, and they are extremely nasty. But there's very little. Certainly, there's sort of the discussions that were held some years ago about cancers and things like that. There's very, very little evidence at all in the literature to confirm that, and indeed a lot of the studies were not done on real exposures but were on potentially estimated exposures. I think the only study that ever showed anything of possible significance was a study in relation to children, but that study has been largely, I think, thrown into a bit of doubt now. So I think we are relatively safe, I suspect, although we still hear very occasionally people talking about brain tumours and lymphoid things and things like that, but the evidence is not good. Thank goodness, considering what sort of things we've been exposed to over the years. But there we are. I won't hold it and say good night to everyone. And thanks very much. It was a fabulous program, and I really have incredibly pleased to have found out about that that museum in Italy with the wonderful videos. And it is absolutely stunning. If anyone wants to look at the YouTube thing, I think the YouTube is Florens FST, and it's got the most fabulous videos as you demonstrated tonight, Chris. That was a really interesting find, and I shall enjoy watching a few of those videos over the week. Good evening, everyone. Have a pleasant week, and chat again sometime soon, perhaps next Saturday. All the best from VK3 Echo Charlie Golf. Now, off and clear.
All the best, Dave, and thanks as always for your input here. I really appreciate that. Keep on hearing interesting things about your experiences from Steve 3SL, who has a huge amount of respect for you, and of course with your work as in tenor music, you have quite a common thread there with Steve. What I'm hoping is that what I'm doing on Saturday nights is kind of the spoken word equivalent of what Steve is doing with more multi-tone material on Friday nights. I can understand where he's coming from. I run into problems whenever I play any music, even from 78s, with copyright strikes on YouTube if I play music. I wouldn't mind playing music. It's no longer illegal, in spite of what some older amateurs might think. but it's just kind of invites trouble on YouTube. That's why I avoid it. Now, Ian on the text box says, is it worth considering or feasible to have call-ins on 145.3 to enable the continuous transmission on 147.475? This would enable listeners to hear all the callers to the program on 147.475. I would love to do that, Ian, and I've been hovering on hamfests for the last 10 or so hamfests to try and find cavity resonators that would allow me to efficiently run crossband in-band on 2 meters. But I really need a cavity resonator to put on the output of the transmitter rather than the input of the receiver to make sure it's all nice and clean. That's the way Dave does it. I know that at a recent hamfest, I think it was the Moorabbin one, Dave bought 4 cavities suitable for 2 meters for $20 each, which is pretty good going. And it's a pity I didn't see them first. So that's the situation there. I do want to get crossbands going again. I did have them going for a while between here and 70 centimetres, but we had that same problem with leakage birdies that cavity resonators would probably get rid of, properly used. So Peter, it's up to you to tie the ribbons. VK3ACZ and the group VK3 VK3 Croak, VK3AML.
Yeah, VK3AML in the soon disappearing group from VK3ACZ. Yeah, well, you mentioned 3SL Steve. I found his music broadcast, I think it was last Sunday afternoon. He was broadcasting on 160 and 70. And it sounded really good too. I can't remember how I found it on 70, but anyway, so yeah, he doesn't just pop up on Friday nights. But, and as for the kilowatt thing, well, I don't have much trouble agreeing with you, Chris. One of the satisfying things I do is when I'm talking to stateside stations, knowing they're running a kilowatt, and I'm still getting 5.9 reports. That's if it's legit, if they're not humouring me. But we're having pleasant rag chews occasionally, so there's no reason to severely doubt them. It's wonderful to think that I don't need the kilowatt to get back to them. So there, it obviously would depend on things like caudal hops and all that if I'm going to get a strong signal over there. But it's good when it happens. And yeah, another good broadcast tonight. Don't forget, put in your diary for Monday night the Sherbrooke on-air meeting, and let's keep our fingers crossed that we're released from the ball and chain that's around our collective ankles is removed sometime between now and Monday week, and we can have our club meeting in the usual digs there. That'll be great if we can, especially if we're going to get a presentation from you truly. Anyway, thanks again for your usual Saturday night broadcast. I'm just wondering, just last question to pose to you, whether you'd be interested in giving us any spoilers of what to look forward to next week. But if you don't want to divulge anything, I'm more than happy to turn up on the night to be surprised. But anyway, you gave us a bit of a hint about what we were going to get tonight. Anyway, it's a real cold one. It's 8 degrees in the shack here, and I see it's 7.9 in Scoresby at the moment, according to the Weather Bureau monitoring. And stay warm, everybody, to all the listeners out there. And Chris, Dave, and Terry, if you're still listening, 7-3. And look forward to doing it all again next week. Or as Terry said, same bat time, same bat channel. Cheers, Chris, and good night, VK3AML from VK3ACZ.
Just listening. Have we got any other final callers before we close off? VK3AML, standing by. No, I think everybody's gone, and including my voice. So thanks for that, fellas. Dave, Peter, Terry. And I see Terry talking about the SDR. Yeah, we might be able to arrange that. Mind you, I can probably use the SDR from VK3, Paul Carlstrand, KAU I think he is. He's up at Croydon. He's sufficiently far from me that I could probably do duplex via his web SDR. But the trouble is, I think there's 30 seconds delay in that, so while it's usable for simplex operation, it becomes a bit cumbersome for using it for duplex. What I might do next week is to do a little video tour of the shack here to show how all of this gets both onto the air and with reasonable fidelity, and also how it gets patched through to YouTube Live, because it is a fairly complex patching arrangement for this, involving duplex cards in the computer and getting the right levels out on net. That's where the audio peak limiter comes in really handy, because I don't have to fiddle with level controls all the time as I've been doing on previous weeks, which probably people have seen. VK3KHZ, that's the right one. Paul. Anyway, with that, all the best to everybody until next week. Thank you to all the people on the text chat. It's been really good. The numbers are actually a little up on what they were last week. It seems every week I do this, it gets a little bit better. And I'm now very used to recording stuff, pre-recording stuff, and getting it out without too much deterioration. So I'll be able to look at recording stuff away from here as soon as I am lacking being chained down to the house by the regulations. All the best, people. This is VK3AML, now closing on 147.475. See you next Saturday, 9:30 p.m. And for the people on the stream, thanks so much for being there. Glad it all worked well. I'm just checking the stats to see that what sort of... We've had not a single frame of drop in 2 hours 53 minutes. That's very good going. Okay, I can't see anything more that I should do here, so all that remains is cheers, good night. I hope you all are keeping in good health. I hope you've all enjoyed in one way or another what we've been doing here, and the experiment is an interesting one from my point of view, assembling all this stuff from week to week. I'll take you on a tour of the filing cabinets here to show you all the written and recorded material I've collected in 50 years of being involved with broadcasting and archives. It's frightening. So getting it together, sort of taking a chunk of it and making it in a form that can be interpreted on a single night, like I did tonight with the early days of wireless telegraphy and GW Selby. I hope to tackle other single issues as weeks go by. GW Selby this week, last week, great audio mythologies. So next week maybe a tour of this shack in more detail. And I was thinking actually of running the video that I will run for the Sherbrooke Club just as a test to see how it goes down on the Saturday, because it'll be run with a video projector at the rooms in full def on the following Monday. So that'll reduce the amount of material I have to produce. It'll be killing 2 birds with 1 stone. Good night, people. Thank you for being there. Hope to see you next week.